Welcome back to the Game Development live stream, everyone. Today's topic is Web GPU. It's a really, really awesome subject that could ultimately be transformative to the way games are built and distributed online. I'm Jon Radoff. I'm your host here today. I'm the CEO of a company called Beamable. We build back-end infrastructure for games. Think of it as like Unity or Unreal, but for everything you got to do in the cloud online. That's what we do. And I'm accompanied here by Oscar, who's our producer and helps organize all of these talks, keeps us on track, keeps the camera moving around, queues up content, and also brings you, the audience, into this conversation. So along the way here, if you have questions about Web GPU, or for that matter, anything that you think is pertinent that happened in game development this week, please speak up on any of the channels we're on. We're on Facebook, LinkedIn, YouTube, Twitch, X. And if you're watching this in a replay, thank you very much for watching however you've watched this, but we'd love for you to come live and online when we're doing these. There's a reason we do it live instead of a YouTube video, and that's so that you can participate and be part of this conversation. So to talk about Web GPU today, I brought into this conversation someone I have known now for the last couple of years doing really interesting work in Unreal Engine with Web GPU, and that's Alex St. Louis from Wonder Interactive. Alex, why don't you introduce yourself?
Hey, can you guys hear me? Can you guys see me?
You sound great.
Hear me? Awesome.
Yes, you're live.
Yeah, it seems to be slowing down a bit on my side, but yeah, great to be here. Thanks for having me, John and Oscar. Such a delight. I've been watching this the show for a while now, so it's super exciting to be on here. Yeah, I'm the co-founder and the COO of Wonder Interactive. For those who don't know, we're attempting to build the future of gaming on the web with WebAssembly and Web GPU. And we firmly believe in a future where game developers can deploy their games to the widest audience possible to gamers across any device. We have an interesting story. So we actually first started out, I actually was experiencing this problem myself of, at the time, having built a small indie project and trying to get it running on the web with Unreal Engine 4. And, I went down this rabbit hole of trying to get it to run and pixel streaming and all this stuff. And for those who don't know, Unreal Engine used to have WebAssembly and WebGL support, WebGL 1. But it was deprecated and removed out of the engine. It never really was that great to begin with, just because of where browsers were at the time and the technology. So that's when I teamed up with my co-founder, and we took it upon ourselves to start building out something more robust and future-proof, really enabling a lot of these key features that developers are looking for, chief among them being compute shaders. What compute shaders gives you on the web, it gives you never before seen visuals, for one, to start with. That's something that now is only possible with Web GPU. Because, again, for those who don't know, WebGL is based off of OpenGL, which itself is quite an outdated technology at this point. You have Metal, you have Vulkan, you have DirectX. But here with WebGL, it was stuck in OpenGL land. With Web GPU, we really get a chance to bring a modern graphics API to the web. And simply what Web GPU is GPU compute for the web. And this is an absolute game changer because, in my opinion, the reason why we haven't seen web gaming as a market really keep up with, not to say that it's non-existent, but the growth rate, the CAGR, of this market is much smaller than, mobile, PC, console even. And the reason for that is because there hasn't really been the tooling to exist to bring native games to the web. You'll see lesser than versions of games that are less feature complete, let's say. And now with Web GPU, really, this is a chance to bring, like I mentioned, compute shaders, ray tracing on the web is something that's going to be possible as well. And the people over at Google are doing fantastic work, as well as everyone else building out the Web GPU spec to enable high-fidelity 3D in the browser. And really, our mission is to bring it has been to bring Unreal Engine to the web, Unreal Engine 5. And we've had great success in doing that as a third party. We've been working with, multiple customers bringing their projects to the web. And all I can say is the future of gaming on the web has never been brighter. And I truly believe that we're going to see a renaissance of gaming in the browser. Yeah.
So Alex, Oscar just a moment ago was posting an article I wrote a while back. I think if you search for my Substack and go to how the web could eat software, you'll find what I wrote about not only web GPU but WebAssembly and some related technologies that could really impact game development. But the audience that comes into this live stream includes a lot of people from game development generally. It also includes people who are just trying to learn more about game development and some of the technology aspects. So let's just take a little bit to kind of start at the highest level. So we've all seen 3D graphics in our web browser before. So it's not like there hasn't been a way to put meshes on the screen or even do 3D scenes. But could you kind of help people understand the distinction between that approach to rendering that some people might have already seen in their browser and how that's different from web GPU on the one hand, or for that matter, downloadable software that they could install and run on your own computer that's using something like Unity or Unreal Engine, where they're also seeing 3D graphics? Because I think that'll help people understand the landscape of these technologies. And then I'd love to just drill into web GPU specifically and how that might open up more possibilities for distribution and actually using the web as a platform for games.
Yeah, no, 100%. So lots to unpack there. So let me just start with kind of what makes web technologies kind of different from native and kind of where we're at. So, I mean, everybody's seen and everybody's probably tried cloud gaming services such as xCloud, or whether you're a developer or an end user, or GeForce Now. And the great things about those technologies and those platforms is, any screen you can get a pixel stream build. The downside for developers is really the cost, right? So that is kind of why, that's kind of the big reason to go client side if you can. Again, to kind of jump back to tooling really hasn't kept up. I mean, WebGL 1, I believe, was released around 2010, maybe 2011. WebGL 2 only made it pretty much everywhere, including iOS, I believe, by 2018, 2019, maybe 2020. But the native engines, if we're talking about Unity and Unreal, Unity has had, way back in the day, they started with, I could be wrong on this, but they had a plugin, a way to do native in the browser prior to WebAssembly. And Unreal Engine actually partnered with, if anyone's familiar with Asm.js, which was a subset of JavaScript for doing 3D on the web. And so this is way back in Unreal Engine 3 days. Epic partnered with Mozilla to get Asm.js to run on the web. And Asm.js was, fantastic. Google also had something called Native Client, and basically the same idea of, similar to WebAssembly, you have an intermediate format that you compile native code to. So you take C++, and you could take really anything, C#, as long as the language supports compiling through mscripten, and then you can run it in WebAssembly. So that's been the approach. Even if you go further back to the days of RuneScape, I remember how much time I used to spend on that. And that was Java. That was a Java web client. And that was a fantastic experience. Even look at original Minecraft, that was using Java as well. And it was no different, right? You're compiling to an intermediate format. And the difference between those approaches and WebAssembly, you don't need a plugin, right? It's a standard WebAssembly and WebGPU. They're both standard, so they're baked into the browsers. At least WebAssembly is. WebGPU is being worked on by all the vendors right now. And I know I'm diving into WebGPU a little bit, but I'll get back to WebGL. But they're basically agreed upon formats by all these browser vendors. And the reason why this is a kind of a big deal is if you look at how fragmented the market is for graphics APIs today, let's say you're a game developer, right? And you want to ship to PCs, like the number one platform there is, you're going to ship, DX12, maybe DX11, right? Maybe Vulkan. If you want to hit Xbox consoles, you're going to essentially build for the same sort of API. What happens when you want to build for iOS and Android and all these other various platforms? What happens if you're building for Sony's platform? You have all these fragmented APIs, and WebGL really, and WebGPU as its successor, because that's what WebGPU is, these are a chance to have a unified platform target. Like the true promise of, and I get giddy talking about this, but write once, run anywhere. There's been a lot of hype around that. I think with Flash was really the first time we ever saw the ability to just publish on the web, put it up once, it runs, school computers, your home computer, anywhere. This is before the advent of mobile. But with WebAssembly, WebGL, and WebGPU, we really have the chance to hit almost every device that a user could conceivably have, right? So it's a super exciting time. I can go more into WebGPU now as well.
Yeah, let's talk about WebGPU. And if you don't mind, while you're going through that, we'll probably mostly talk about graphics as it applies to game developers, but we should also remember that the GPU is also where computation for things like AI inference happens today. 100%. So a potentially even larger application of WebGPU in the browser would be doing device-side inference where you can run it in your browser, which is really interesting to think about. So I'll turn it back to you, though, to maybe go from like WebGTL to WebGPU. What advantages does this now bring graphics rendering and also AI?
Yeah, no, 100%. So the main thing that I would really say is that the jump from WebGL to WebGPU, once again, is compute shaders. So you're finally, I know we're catching up with like pre 2010 technology here, but we've never before been able to do compute shaders on the web. And that is such a game changer, specifically as it pertains to our implementation of Unreal. This means
and Alex, just for a moment though, just because again, there could be a lot of people tuning in, even in game development. I'll tell you, when I talk to game developers, unless you're a tech artist, no one knows what the heck a shader is, by the way. Like a few people use that word. They don't really know what they're talking about unless they're actually like an implementer doing shader graphs or shader code.
Shade,
Yeah, just kind of give us an intro to like compute shaders. We don't have an hour to go through like all the different things that shaders mean, but like quick intro to like why this is relevant in WebGPU specifically relative to WebGPL and other previous technologies for rendering on the web.
Yeah, no, 100%. I'll just kind of do a TLDR version or a nutshell version of what a compute shader is. So it's a small program that's written, batched, and essentially run on the GPU. And this translates to the GPU telling your screen what to render. And the reason this is a big deal is because GPUs are parallel. They work on parallelism, right? So the idea of being basically parallel. And so, yes, there are general purpose computations. And the nice thing about this is that you can really enable, again, it mentions more complex with the Google Gemini summary. And that's exactly what I was getting to is these complex applications. I love having notes on screen. It's great. It really enables these more complex applications. With WebGL, you couldn't do that parallel compute. So parallel compute is the one takeaway I would say to anybody listening in. You can do so much more with less, right? Before with WebGL, you were hamstrung. You couldn't, even if you had a 4090 or 3090 or whatever, or M series chip, you couldn't squeeze all the juice out of that lemon, so to speak. Even if you could run something super, super complex ray trace client side natively as a PC or a Mac application or what have you, as a native app, you wouldn't be able to have done that, the same functionality one-to-one, like feature parity on the web. And even still with WebGPU, there are a few caveats. So if anyone's familiar here with shader models, shader model 5 and shader model 6, shader model 5 is roughly equivalent to, a DirectX 11, DirectX 12. Shader model 6 is kind of the new kid on the block. So it's like DX12 plus. You have certain features like ray tracing, like Nanite and Lumen from Unreal Engine.
Mm-hmm.
That's not something that runs in WebGPU today. The browser vendors are going to essentially have to add the capabilities to do that. But so we're still behind native. Like we're going to catch up. Like we're going to get one-to-one with native at some point, I believe. But even today, the way to think about it is with WebGL, you could do 90s graphics, maybe early to mid 2000s at best on the web. With WebGPU, you're getting the ability to do, I believe it's at minimum 2014 to 2015 looking games. So something like Witcher 3 could run on the web today with WebGPU. Mm-hmm. Something like an Overwatch or a PUBG, but yeah, that's essentially kind of the capabilities and the feature sets on both. And WebGL, I don't mean to diss on WebGL. WebGL is fantastic. I know there's a great group of maintainers at the different browser vendors. You can do so much, and we owe a ton to WebGL. That's what we started with. And WebGL will always really be a thing for the foreseeable future. It's a fantastic fallback for those that don't have WebGPU capabilities. And one more thing I'm going to mention too on the subject of the different APIs is there's something called WebGPU compatibility mode. So what is WebGPU compatibility mode? Let me explain. So essentially, there's many places today where only where you can only run WebGL. So think older Windows devices, Chromebooks, things of that nature, right? Witcher 3 on the web. Yeah, I'd like to see it. So WebGPU compatibility mode is attempting, and this is in Chrome, I believe they're testing it in dev branches, but it's soon going to be part of the WebGPU spec everywhere, is WebGPU compatibility mode, or compat mode for short, is going to run in all the places that WebGPU doesn't today and WebGL runs. So what does that mean for features? You're going to get compute shaders as a baseline. You're not going to get every single one of the bells and whistles in terms of you're still going to have fantastic performance. You're obviously still not going to have ray tracing, but it's going to be a nice middle ground, a nice compromise. And I mentioned WebGPU compat mode because I haven't seen a lot of talk online about it. My co-founder and I are very, very excited about it. It just means getting WebGPU to more devices and getting modern graphics to more devices, especially ones that are a bit more, let's say, constrained hardware-wise. I know I went off on a bit of a tangent there, but feel free to reel me back in.
So a big question that I think game developers will have in general is, how ready is this technology to actually ship my game in from both the maturity of the technology? Like, is it really ready to ship a big game? Like we had that comment a moment ago, Witcher 3 on the web, is that in theory, or could you actually ship a game with that depth and scope to it? And also just from a pure sort of, does it run in the browsers on all the devices that I would want to target, including maybe older devices, which are still important for someone to be able to ship a game to? So thoughts on just that distribution and accessibility side of the technology?
Yeah, 100%. In terms of commercial viability, I'm just going to do a quick call out to a fantastic project that's Unity-based called Project Prismatic by Stratton Studios. If you guys haven't seen it, definitely try it out. It's fantastic. To my knowledge, that's the first. I know they're doing the episodic series, so they're doing their game in parts, but that's, to my knowledge, the first true commercial game shipped in WebGPU. So congrats to those guys. I do see a lot of studios and publishers in the future, and the not too distant future, choosing to deploy to WebGPU as a means to reach users on more devices. Feel free to run the video if the viewers want to see get a brief glimpse of what that looks like. Yeah, you can play that on like Crazy Games on Stratton Studios website. I've played it; it's great. And this is something that I don't think you would have been. Maybe you could do in WebGL. I don't think it would look as good, nor would it perform as good, nor would it reach quite as many devices. But yeah, that's a good one. I wanted to make sure to mention them. In terms of, let's say you're a game developer today and you want to ship on the web. Maybe you're worried about storage or not storage, but rather system requirements and memory and just loading a multi or tens of gigabytes game on the web. I want to just mention the importance of load times on the web, because I know the web is a newer platform for a lot of developers, and load time, I'd be amiss if I didn't mention it. So for every second or two that you have a loading screen, you're just churning users, right? So the web, you need to be very considerate of load times and performance. And this is a bit, I will say, it's at odds with AA or AAA experiences, heck, even some indie experiences. That's why it's very important to not load everything at once. I know that the Stratton Studios guys are doing this with Unity's addressables. We're doing it with Unreal Engine in terms of our asset streaming system. We've actually built out a custom file system that loads into memory at any given moment exactly what you need and nothing more. And it's constantly unpacking previous game data from like an area you just left, whatever you just used, it's getting rid of it, and it's loading in what you need at any given moment. This means you don't need to have a 6 gigabyte, a 10 gigabyte, heck, 100 gigabyte game in memory at once. You're never going to need all that. You're asynchronously going about grabbing what the player needs to see at any given moment. And this is something that is a must. It's not like a nice to have. You need to have this. Like, otherwise, I mean, people are going to churn. They're not even going to get a chance to get into the loading screen of your game. So that's something we've addressed by building out our custom file system. I know Unity's working on this. There's a few different implementations for different engines. Compression is another big thing as well. Just to loop back around to what the question that was actually asked, if you're a studio today and you want to ship on the web, could you ship something like Witcher 3 on the web? The answer is yes, with some kind of caveats. So if you're not using something like, let's take Witcher 3 on the web, right? If you were not using asset streaming, if you were not using compression, if you were just trying to upload it to the web and compile it to the browser. I can see my co-founders chiming in here. If you're not going it about the right way, it's not going to be a great experience. But using our technologies that we've built at SimplyStream, it's 100% possible, and it can be done today. I know a lot of people have concerns about the storage in browsers. Again, it's not really an issue with our asset streaming. Chrome as well just recently upped the ability to have more memory for your application. So I believe it was memory 64. So going from 4 gigabytes to a higher limit of what your total native PCs or devices address space is. That's going to be a key unlock as well for getting these big experiences client side. And yeah, something like Witcher 3 is totally possible today. I'm just reading this question here. Curious about file system access. Yes, so that's a fantastic point, Josh. Thanks for your question. I really appreciate that that you mentioned that, because yeah, absolutely. That's a very good analogy. The great thing about client side is you load it once and then it's cached. So why does this matter for developers or for users? Because you can persistently store this game, right? Think of your browser like a native game launcher. It's no different, right? Once you load it, it's on your device, unless you're clearing out your computer's history, or you're turning your device on and off. That data is going to persist, and you don't have to go through. Maybe it takes a minute or 2 minutes or 30 seconds to load up the first time. it's going to be subsequent, a few seconds, sub 10 seconds, depending on the specific title. That's one of the great things is the caching system that's in browsers by default.
But I guess the big takeaway for people to start thinking about is sort of, yes, you can, in theory, compile a web GPU version of Witcher 3, do no changes, and download a multi-gigabyte file. Actually, I think there are browser limits on how much you can download in one go of file content as well. But at least in theory, you could have a big download that contains everything, but no one's going to sit there waiting every time you go back and reload the file. So that doesn't work. So you do have to think about a somewhat different paradigm around the way you structure the game so that you download a very small binary that streams assets into your browser, which is something that mobile developers have been kind of doing for a while, even without web GPU, just because with mobile games, people are accustomed to the idea that like you have to have a quick download for the first time, and then there has to be some immediacy to the initial experience so that people get in and play. So that's a big change. And while you're thinking about that, I also just want to thank the folks who have posted those comments and questions. Thanks, Joshua. Thanks, Robert, for joining the conversation and posting that. This is a live conversation, and I see 319 of you in the audience right now. So we're literally bigger than most of the talks that you can attend at GDC already. And we're here talking about web GPU with an expert in this technology. Web GPU is something that's really going to change the way games are built, shipped, distributed in the coming years. So I would love to see more and more questions. Great to see those early ones. Jump in, post a question on LinkedIn or Facebook or YouTube or X, any of these places where this stream is. And we are happy to bring those questions on screen and have you be part of the conversation. By the way, Oscar can even pull you in live if you've got a camera. We're happy to bring you on the stage if you've got something to talk about with web GPU or game development this week. We'll bring you right in. So
something relevant,
Alex.
Something relevant to the conversation.
Yeah, something pertinent. Do your best so that Oscar doesn't have to throw you off the stage or something. No, we'd love to have you come and take part. So Alex, how long do you think we are to getting to the point where games will start to build with that streaming methodology so that they are much more web GPU ready? And how much effort is that to take an existing game and essentially go through and refactor it for streaming if you're like 2 years into development of your game already and you're a year or two from shipping, since that's how long AA, AAA games take to build? Like, how feasible is it to do a course correction and take advantage of this technology?
Yeah, no, 100%. So today, as it stands, I'll speak to our technology and our implementation. So our custom file system and the asset streaming system that I mentioned earlier, if you have a build, it's pretty much automatic. It's just like making a build for any other platform. We now have a plugin available that we're offering, and it makes it essentially a very seamless operation. There's going to have to be, I think, in the industry, kind of developers are already aware of the sensitivities around load times and performance on the web, specifically load times. But as it pertains to us, it's pretty much an automatic thing. It can be done today. There's no refactoring that's needed for a company. But the tooling is really the big thing that hasn't really existed for native engines to date to be able to do this in a proper fashion, I will say. But yeah, it's just like you need to optimize your game for any platform, right? You wouldn't ship a game that hasn't been QA'd and optimized and all that, right? For any other platform. It's no different for the web, but extra consideration needs to be taken. But yeah, say you had an Unreal Engine 5 game using our tooling, you could make a build. We have our asset streaming basically hooked into that. So when you make a build, when you go into your project launcher and you go to make a build to package and publish to the web, it's pretty much an automatic process. And that is the way that it should be. It should be integrated into it should be very easy for developers, like 1 click, 2 click, that's the way that we see it.
Are we possibly going to have, I know that there's some technologies that aren't all the way there yet, like ray tracing, nanite, lumen, all these sort of native features of Unreal Engine that aren't in WebGPU yet. But how close are we to, in addition to the web-based distribution, when you download a game in Steam, does it even need to be a native binary anymore? Why not just ship a thin client web browser that points to the web page, and that's the game client for distribution on every other platform out there?
No, that's a fantastic point, actually, and I like that. I've been thinking about that for a long time. Like, you can take something like Electron, which essentially you can put a native wrapper on, just like you mentioned, John, on a web game. And I know actually there's a favorite game of mine called Crosscode. I'm just going to give it a quick shout out. They actually do this. It's an HTML5 native JavaScript built game, and they actually just shipped it on Steam. Very popular game, and it's actually a browser game. They didn't do a native version for Steam. Like, there's blog posts and write-ups about how they did this, but essentially they took a web version of their game and they shipped it everywhere. At least the web version was used on Steam. I know that for a fact. Not 100% sure about console, but that's a great example. I know some of these IO games, I can't remember the exact names, but some of these IO games have shipped on mobile app stores. There's Crosscode. And yeah, there's been a lot of examples. Vampire Survivors is another big one. They didn't actually use the technique that I just mentioned. However, it started as a web game, so I think it's interesting that it blew up on native with, I believe they did a native build. They didn't put that one in a wrapper, but I think there's going to be more and more of this. I think for developers, these engines already have a way to build for every platform, like pretty seamlessly, right? But again, if you can minimize the amount of builds that you have, if you can use one build in like 5 or 6 different places instead of having that many builds, right? I mean, less complexity, less headache. Why not? I think we're going to see more and more of that. And my co-founder rightly mentions progressive web apps. That's a really exciting opportunity on mobile specifically, as well as computers as well, like Windows and Mac. But this gives you, for anyone not familiar with PWAs, this gives you a native app-like experience using web technologies. So you can have a web app that looks and feels just like a native app, and it's indistinguishable. So you get the best of both worlds. You get both web and native, which is a very powerful thing. It's like kind of like peanut butter and jelly, if you will.
Right. And with a PWA, it's packaged as an app on your phone. So it's not like you're bookmarking a page in your web browser. It's literally an app like all the other apps on your phone, and it just happens to be executing a web browser to allow you to experience the app. And if you're using WebGPU, that could be a game. You probably wouldn't even know.
Exactly. That's the beautiful thing about it, is you don't even need to know that you're playing a browser game. Your favorite game that you play might be a browser game packaged and camouflaged as a native application. So
I'd like to zoom out the camera lens again and talk about the business implication of that too, in terms of what is this going to mean for game distribution. So right now we are very oriented around a lot of the major distribution platforms. So if you're a PC game, you're more or less dependent on Steam right now. If you're a mobile game, you're in the App Store or Google Play, and that essentially controls your destiny and takes 30% of your margin. So I'm not going to say these things are going to go away. They're very effective distribution points. Maybe they'll still take their 30%, even if it is web GPU game a lot of the time. But what does this do for distribution in general? And also, by the way, it could be pertinent to the distribution question or anything else. If you want to show anything around web GPU, like the work that Wonder
Yep.
Interactive has done with your technologies. Would love to just drill into those and show people some things. I was showing a little earlier just some real quick demos off my X feed, not of your technology, but things that people were messing around with in WebGPU and creating shaders, which I thought looked pretty interesting. But let's start with the distribution question. What's going to change in the coming, like maybe it won't change overnight, but in the next several years as this technology becomes more standard and people are streaming game assets and we've overcome those kind of issues, what happens to the way we buy and find out about games?
Yeah, I know. This is personally what excites me the most. I think that, we're about to ride this rocket ship of easy distribution, easy to use tooling, and then for users, it's a win-win. Like for developers, it's a win-win because you get more eyeballs on your game, more platforms, more devices, one single entry point, right, across all of these different hardware devices. I think for distribution, it's the most fascinating kind of question because we've seen what's happened with different game developers that are speaking out against, quite frankly, what I would call injustice by the app stores. Like Apple is taking 30%, and 30% is by no means, I'm not going to sit here and say that it's not a fair deal. 30% is pretty standardized. Steam charges 30%, but a lot of developers are glad to give that 30% to Steam. So why is this such an issue on mobile?
And it was 60% years ago when we had to buy games from Walmart.
Exactly. And you'd have to give a piece to a publisher, right? So 30% is a pretty decent deal, especially with the main value add being the eyeballs. But guess what? You can get way more eyeballs on the web. So let's take a look, for example, at the app stores, between iOS, which I believe is, far, far north of, 2 billion plus users, or close to. Android is much, much higher than that. The interesting thing is we're already seeing, because Google has the ability you can sideload app stores on iOS. There's a lot of litigation going on about this right now. And so it's interesting. It's an interesting question because, we're starting to question the value that these distribution marketplaces actually have. And, Apple saying, specifically around security and reviewing these games, I know there's been comparisons to they're just a payment processor. I don't agree with that. I think that, again, these are great discovery mechanisms to get eyeballs on games, but I'm just going to go back and say that the web is a better one, in my opinion, because the web reaches iOS, the web reaches, rather, Android. It reaches all of these different devices like PC and Mac. So why use a single store constrained to one device type? When you could use one distribution method that reaches all of those devices that the stores are already trying to cater to. And again, it just simplifies developers' lives. You can do commerce directly. Like D2C is a big kind of thing right now with web shops. We're seeing like different companies like Stash is one. I know Xsola is doing web shops as well. The ability to do business direct with your customers, with your users and your players is a big, big deal. And we're personally seeing this. Like we're working with different companies that are very bullish on bypassing these app stores and bypassing these siloed walled gardens, right? Maybe they still ship on those walled gardens, but they want a new way to reach customers. And just to look back at mobile, user acquisition costs have always been high. It's never been harder for a game developer to get discovered today. I think on Steam, there was something like a couple 100,000 games that were added just this past year alone. How do you get discovered in that, right? There you go. Something crazy like that. 19,000. It sounds just impossible when you quote numbers like that. But on the web is really a blue ocean opportunity. There's not as many people doing it now. I believe that there will be. Will there be 19,000 games a year uploaded to the web at some point? I believe so, yes. But that's why the time is now to be learning about these technologies like WebGPU and WebAssembly, using the SimplyStream platform to bring your Unreal Engine 5 projects to the web easily, effectively, and affordably. And yeah, I think I answered half your question. There was another one in there. as well.
Well, I was going to invite you to show off your product and your tech at
Yeah.
any point as well. But while you're
Yeah.
thinking about that or figuring out the things you want to show, like I have a lot of thoughts on this too, which is,
Yeah.
first of all, if you think about all the times you're on the web and you're hearing about a game and you want to check it out, and it sends you to a Steam page where you're
Yeah.
learning about the game and seeing a YouTube video and reviews and
Yeah.
whatnot, in the future, that link might just be to a web page where you just play the game. So the
100%.
immediacy of that
Yeah.
increases a lot. And then you can think about the whole software ecosystem around that. In addition to native websites, there will be any number of new portals and directories
Yeah.
for web games. Like before the show started, we were talking about Newgrounds, and there have been others
Yeah.
like Congregate and others like
Yeah.
that, where their tech couldn't really keep up with modern gameplay. So they tended to be like Flash games originally, and then sort of very casual games later on that
Yeah.
use web tech. But they could, those kind of portals could be a way to access the most advanced games that are shipping. And you could also think about things like instant messaging platforms. Like you've got Discord, for
Yeah.
example, which has been doing
Yeah.
more and more with embedded gaming. You've got
That's right.
Telegram, which had some decent success in the last year as a essentially a gaming platform. But again, initially kind of around HTML-ish kind of game
Yeah.
experiences. There's no reason to think that it won't be push a button out of the social network you're on or the messaging
Yeah.
platform that you're on, and you're jumping into a game experience with your friends at the same time. Or just as a parallel idea, think about Roblox and the way that works. I'm not saying that necessarily Roblox will be doing anything really special with this tech. Maybe they could, but if you think about how it works, it's a portal of lots of game
Yeah.
experiences that you play. It has to launch their browser, if you're on the web, to their browser, their viewer essentially, to play the game experience. But what makes it really work is the fact that it's part of this social network where you jump around to different things with your friends and try different things together. But in the future, that could be the web itself, to go and play those games without the barriers that currently exist, which are really just technological. It's just that you can't run truly modern game experiences in your web browser today without something like web GPU.
Yeah, exactly. No, I couldn't agree more. I think I think when we talk about in context to web games, I think everybody has a preconceived notion about what they are. They think, again, to go back to RuneScape or Club Penguin or maybe different IO games. But a lot of people don't know that Stumble Guys, which is the popular kind of counterpart to Fall Guys. Stumble Guys, for context, is made by a great mobile game developer called Scopely. They actually shipped a WebGL version, and it's one of the most popular web games today. I think the only way to get that is through their own website. That's one of the most popular mobile games out there, and they just quietly shipped a web game. They've linked out to it, and they've seen fantastic success with onboarding users and players from demographics that wouldn't normally play PC games or play or have a Steam account. I think emerging markets is another thing to mention. I think people are looking for these, especially smaller experiences. I think this is what we're going after, is there's an appetite for larger experiences as well. But yeah, like a lot of people, they look at something like Stumble Guys and they say, you can't really do that on the web today. Well, you can do a lot more than that, but I think, again, we're going to see more and more what you would see as not just native games, but like console and PC games come to the web. And I think the beauty of the web, like you mentioned so correctly, John, is the immediacy and the elimination of friction, when all you need to do is click a link to send, to quickly jump into the game, or to get your buddy into the game. That sort of virality that you can have, whether it's embedded directly into Discord, or it's through your own website, or it's on another social messaging platform. I think many don't know that YouTube has their own browser games that they're starting to push. And the common kind of thread here is a lot of these are these simpler, maybe higher end mobile games at best. I can't wait to see more desktop quality games, like keep mentioning Witcher, something like that on the web, or a PUBG. I love first person shooters, so I'm just waiting for a super high fidelity first person shooter on the web. But I would like to, in the spirit of kind of talking about more lightweight experiences, I do want to shout out Crop Out, which is a game, a sample made by Epic Games that we've ported to WebGPU and WebAssembly. I believe we have a link here as well. Are we able to bring that up?
Yeah, give me a moment. Oops, out of memory. Let's see, let's reload that.
Yeah.
Oop, oop, oop.
And yeah, this is a really great showcase for what you can do on the web. This is an Unreal Engine 5 build. It's was made for mobile, but of course it runs great across Mac and desktop as well. This is using our asset streaming system as well, so downloading of assets, and this is the subsequent load that's happening here. This is the second or third time I think we've loaded it up, so it will be much quicker than the first load. But there we are. Now it's loaded, and hopefully the audio comes through because the audio is just great. And you can see here a simple kind of top-down builder kind of game that you can jump into. And you can play this in your browser today. I'll post this in the comments for anyone to go see and check out. And I hope you enjoy the experience. And again, congrats to Epic Games for such a fantastic sample in Unreal Engine 5.
Alex, as we wait for this to load up, and obviously this is showing sort of one of at least the near-term downsides of like streaming is going to just have streaming the assets. We'll just have to get a more efficient to bring total immediacy to it. But it seems like the main competition for this on the web is going to be all these emerging pixel streaming platforms. So I think some of the pixel streaming guys would say kind of like, well, forget WebGPU, like the way to actually get immediate access to gameplay through your web browser that kind of jumps onto your stream fast is just use pixel streaming. And granted, there's costs of that in the cloud. It means that now you've got 2 GPUs basically for every game, the one on the client plus the one in the server that's running and streaming the video to you. What are your thoughts though about pixel streaming versus web GPU as the web native mechanisms for delivering immediate 3D graphics experiences?
Yeah, I have a lot of thoughts about pixel streaming. I guess I neglected to mention at the start, but we went all in on web GPU, of course. It's got its pros and cons. You can think of each of these technologies as a different tool for the job. And so each one is going to be better suited for different types of experiences. So Unreal Engine 5, you might traditionally think, oh no, that can't run in web GPU. That can't run locally on the web. That can only run pixel streaming. That's incorrect. But for the highest end, maybe Unreal Engine 5 experiences where you're using Nanite and Lumen, these advanced shader model 6 features, and you want to run it on, let's say, something without an integrated GPU even, or just an integrated GPU rather. Is that going to be a good experience client side? Obviously not. That's where pixel streaming comes in. So again, back to using the right tool for the right job. And pixel streaming, we have our own pixel streaming solution as well. I didn't mention that we are a hybrid platform for delivery of games and 3D content. We not only have the client side, we have the pixel streaming and our hybrid, which I'll get more into in a second, as fallback methods for devices that don't have web GPU. And so we've developed out our own pixel streaming with leading edge features such as I'll mention AV1, which lowers the bandwidth that's required to do a pixel stream. Very advantageous. So it makes it super, super low latency. We're also able to do this at a far more cost-effective way. One of the big complaints with pixel streaming is that cloud gaming, if you're renting GPUs from a server, are you going to have the business model to support that? And so one of the things we're really working hard at is, and we have a pixel streaming solution that's in early access right now that we're continuing to develop out for our customers, is just making it as easy to use, drag and drop. You can upload a Linux build and very soon a Windows build as well. And then out on the other side pops a pixel streaming build that runs in essentially every place, no matter, if you have a GPU or you don't. And that really gives the best of both worlds, right? So I wouldn't say any technology is better than the other. They're not in competition with one another. Again, use the right tool for the right job, and ideally have an automatic mechanism that can deliver client side when you have client side capabilities. And so we have the ability with our platform to auto detect if a user can run the experience locally. And so we do a quick scan, right? And we say, we benchmark and say, can this device run it locally? GPU equals 4090. Okay, yes.
Yeah.
Then we deliver a client side, or an M series Mac maybe. GPU equals no. They automatically get a pixel stream build. And so that's been our solution. And that happens at instantiation of the build. So it's a very seamless process for end users. And for developers, it's, of course, they can toggle which method they want to use, or they can have the automatic switching that I just mentioned. But we don't, again, just to summarize, we don't see these technologies as in competition rather with each other. They're really complementary technologies. That's the key point that I would emphasize there. Yeah.
Interesting. So they coexist side by side, and you could even deliver the same game through both pixel streaming as well as web GPU without actually making a choice between that, which is an interesting thing to think about.
Yeah.
What's the timeline of these technologies? So we were talking about web GPU a year ago. We haven't quite seen Witcher 3 in the browser yet. Like, what's your thoughts over the next year, the next 2 years, the next 3 years? Like, when will this technology roll out, and when can studios start seriously thinking about it as the delivery platform for their next game?
Yeah, 100%. So the answer is now. Like, you can bring a complex, high-end, high-fidelity game to the browser today if it's Unreal based. Even I had mentioned earlier that we can't do Lumina Nanite. That's partially true. So if you want hardware accelerated ray tracing in the browser, not possible today. If you want software emulated ray tracing with a slight performance hit, that's possible, and something that we can develop out for anyone interested. But I would just say that I can't really speak to much of our current clients, but there's no reason why you can't bring an existing PC or console title to the web today at similar or even matching the fidelity of Shader Model 5, which is that DX12 Metal Vulkan feature set and visual fidelity corresponding to that. And so I'd invite anybody here, if they have an Unreal Engine 5 game that they want a path to bring into the web, please get in touch with us. We're more than happy. We provide porting services, and we also have our plugins available through our plans as well for any companies that are interested in trying to make a build themselves. And we support all the most recent versions of the engines, like 5.0 all the way up to now 5.5. And I would say, in terms of your question around why haven't we seen anything, I would just say stay tuned. That's what I would say. Stay tuned. Keep an eye on the space. Watch the space. So
part of it is generalized game engine support too. So your focus has been on Unreal Engine. What are you seeing in terms of the broader landscape of game engines? Unity, of course, being really important for game developers, and other up and coming game engines, Godot, et cetera, in terms of what you're seeing for web GPU support?
100%. So I actually just double checking here. Yeah, Unity 6.1 beta was out since January, but I noticed I got an email this morning saying that 6.1 is officially live, and they've had web GPU support in experimental for a bit. You could enable it. Now, I believe, quote me if I'm wrong, you can officially export from the engine. It's an official new platform target. They just call it web, but you have as a subset WebGL and WebGPU. So Unity's there. Unity's going to continue to improve. I know they have improved mobile support that they're working on. Brendan Duncan, I'll give a shout out to him. He's doing God's work over at Unity, and the whole Unity team is just, they're doing fantastic. In terms of our implementation, we're just a third party working on, because we wanted to see Unreal support. So we're just doing that, like we're building that out, right? For companies that want it. And in terms of other engines, I know that Godot has, you can find, if you search the web, there's a lot of, there's a trail on GitHub of different maintainers of Godot, however you say it, working on.
I don't know if it's Godot or Godot.
It's up in the air.
I actually should,
we don't know.
Should find that out someday.
Yeah, I think
it's like waiting for Godot.
Yeah, 100%. But yeah, Godot. I always say Godot, but Godot, they have WebGL support. They're working on WebGPU. I don't know their timeline, so I can't speak for them. Play Canvas is a web-only engine, so of course they shipped a WebGPU implementation not too long ago. 3JS, I know some of these non-game engine 3D frameworks have WebGPU support that they're continuing to develop out. I'm just going to go out on a limb here and say it is very important for the native engines to get it, into the engine as a supported feature. It just, it makes developers' lives easier, right? I think that we've seen some engines that are web-based or web GPU only engines, which is intriguing. I think that's very interesting. I know the guys at Amber are doing something with that. I've seen different other things like that. But moving forward, I'm just going to speak to Unreal. I mean, the games on the web today are currently dominated by, I would say, Unity WebGL, as well as Game Maker, Phaser, a lot of these lightweight 2D ones, and Discord even right now, they're offering a lot of embedded web games, but almost, I don't believe they have any Unity. They may have some, but most of them are lighter weight than that, like Play Canvas or custom engines or Phaser, like I mentioned. But Unity is proliferated pretty well on the web these past few years with WebGL, and it's going to continue and be even bigger with WebGPU. We're quite excited about what we're doing with Unreal, because Unreal, I don't want to speak for anybody, but Unreal historically, I don't think anyone can remember shipped like a commercial web game shipped with Unreal. I know there was the fantastic Epic Citadel demo, which maybe we can bring up. Maybe there's a video somewhere we can bring up with that. That's Unreal Engine 3. If you type Unreal Engine 4, you can find some fantastic WebGL demos. Unreal Tournament is the other one I could think of that was UE3 that was ported to ASM.js and then WebAssembly. But we're personally really excited about what this could mean for bringing Unreal games, especially like maybe like well-known, like maybe I can't really think of a game right now, but like a PUBG, maybe something like a PUBG could easily be brought to the web. So something of that nature, I think free to play or multiplayer would be a fantastic fit for the web, and there's no reason it can't be done today using our tool set. So I'm quite excited to see Unreal's market share grow enormously with our tooling and our platform. And again, if you're an Unreal developer, please reach out. We'd love to, work with you to bring your game to the web. So,
excellent. Well, we're coming right up on the end of the hour here, so I'll leave the final word for you so that you can comment on what people should just take away from this and where they can continue their web GPU learning journey, because I think it's a technology that absolutely everybody in game development and just 3D graphics generally has absolutely got to know about. I'll give a shout out to the stream we're going to do tomorrow. So tomorrow we are going to be talking to Koi Network, who are building a decentralized compute network. So we're talking about GPUs a little bit there too. It's a way that you can actually provision compute online for your application, not so much for the client side, but online in the cloud. So if you built like an AI agent application, for example, and you wanted to run your own models instead of just go off of OpenAI or something, and you need a lot of compute to run these agents, you just provision compute for that online. They spin it up off a decentralized network and do that. So I think it's interesting tomorrow to talk about decentralized compute, AI agents, and sort of that whole intersection. That talk is going to be tomorrow at noon Eastern time. Next week, we're going to take the week off because I am at Token 2049 and it's in Dubai, and the schedule is really hard to cope with for doing live streams. We're going to use that week to assemble together sort of the best of so far, and we're going to extract sound bites out and do a supercut to show you more of the conversations that we've been having. But it's been a really amazing journey over the last couple of months that we've been doing this, because we've talked to leaders in technology and game development and Web3 and decentralized tech and artificial intelligence. And I'm having a blast doing this. I know you are too, because we're getting so many people watching these things, and we're going to keep doing it. So thanks for taking part, you, the audience. Alex, take it away here. Web GPU, where do people go next? What do they need to know? Wrap it up.
100%. Thanks again, Jon, for the fantastic live stream. Happy to be part of this and share the Web GPU dream far and wide. Yeah, so I'd invite anybody, again, a call to action, anybody that's building a game in Unreal Engine 5, whether you want it to run locally, you just want it in the browser, however you want it, we can help with that. We're a one-stop shop platform and suite of tools for easy, effective, and affordable distribution of games and 3D content to the web, utilizing 3 different backends: Web GPU, hybrid, and pixel streaming. And yeah, join our Discord as well. The future of gaming on the web is very bright. I think personally, I have a lot invested in this, and I'm a big believer in the web. And I could go on and on and on about what Web GPU is going to enable for AI, because I think that needs to be talked more and more about. But for games specifically, which is more closer to my heart, we're going to see a renaissance of games on the web, and we're going to see a new market emerge and a new method of distribution, which I think is really exciting. I think we're going to see novel ways to play. Like, we're going to see emergent games come from the web, just from the fact that they are made for the web, right? So how can you play to the strengths of the web as a platform? Well, virality, deep linking, the ability to just like hop into a game. I personally think as well, live streaming platforms such as YouTube, Twitch are going to be well suited for these types of experience. Imagine the original dream of Stadia, where you could have a streamer streaming a game, and then the community could jump in. Like, imagine we had a game going right now, we were playing, and the audience could jump in and co-create, if it's a UGC game or just battle it out in some sort of shooter game. I think that's going to be super novel and unique and interesting. And I think that Unreal particularly is really going to shine using our technology, and I can't wait to see what sort of games developers out there are going to build with it. So yeah, if you have an Unreal game, please come talk to us. I believe we're going to link our website and the Discord in the comments. And yeah, thanks for tuning in. And again, thanks Jon and Oscar for having me. It's been a delight. So
yeah. Thanks, Alex, so much for being here. Really appreciate your time. You've shared a lot of wisdom and alpha with the audience. We'll have to do a web renaissance panel at some time as a live stream. We can talk about the convergence of web GPU and decentralized compute and WASM and payments that are web-based as opposed to on iOS. You know, all those things are happening concurrently and could together just change so much about how software generally, but game development in particular, happens. So stay tuned. We'll let you know when we put that panel together. Alex, you're welcome to join us again when we do that. Until next time, thank you so much, everybody who's tuned into this today. We love to see you live. We love to see you watching the views of this on YouTube or wherever you're finding us. Definitely share your comments. Let us know what other kind of content you'd like to see. And I would be remiss if I didn't say, if you're on one of the platforms, you can do this. Follow, like, subscribe. We appreciate all of that. It lets us know that this is the kind of content that you love to see. Thank you so much, Alex. Thanks, audience. We'll see you next time. Take care.